Welcome, and thank you for joining this webinar from Orbit to Everywhere, Comprehensive Assessment of Modern Space Communication, prepared by Alpert Research Team. Let's bring this down to earth and talk about the practical impact of LEO on global connectivity. That low latency changes everything.
It means LEO can finally support all those interactive real-time applications. We're talking video conferencing, financial trading platforms, online gaming, and the speeds, typically 25 to over 100 megabits per second, make it a direct competitor to fixed broadband services like cable and DSL.
And with intersatellite links, the reach is truly global.
You're reducing the dependence on having ground gateways everywhere. You can provide service over oceans and the poles. It's a massive shift.
And the socioeconomic impact of bridging the digital divide, that's probably the most important outcome here.
You can now deliver the same quality of experience to a rural village as you can to a city. And that enables so many critical services. Telemedicine, e-banking, virtual classroom, all powered by reliable, high-speed internet.
And it's not just for emergencies or underserved areas.
The Alpert Research Team pointed out that in a market like Thailand, where fiber is actually affordable, the service found a niche with people who live just outside the fiber footprint but have the money to pay a premium for guaranteed high speed. It proves the demand isn't just about poverty, it's about access to quality.
Let's shift to the broader market and the huge diversity of commercial applications that are being enabled by this new, reliable satellite tech. It seems to be touching every major industry.
Let's start with mobility and connectivity. The maritime and aviation sectors are enormous drivers. In-flight connectivity, or IFC, is a big one, but it's not just for passengers. Airlines are using it for essential operational data, like real-time engine telemetry. We're seeing companies really expand their footprint in IFC by leveraging those advanced ESA antennas we've been talking about.
And what about for media?
News gathering is still a classic use case. You have these mobile truck-mounted antennas that let a news crew broadcast a live feed from literally anywhere in the world, bypassing any local infrastructure problems.
Okay, what about industrial and enterprise solutions, where things like business continuity and IoT are the main drivers?
In banking and finance, satellite provides critical backup connectivity, and it also promotes financial inclusion. You can have ATM networks and remote bank branches in underserved areas that use VSA or LEO links to securely connect to the central systems.
For energy and utilities, it's all about monitoring remote assets.
The energy sector uses satellite IoT to monitor smart grids, pipelines, and especially renewable energy sites like remote wind farms that are often way outside of cellular range.
And the same applies to agriculture.
Agriculture optimization or precision farming. Satellite IoT connects remote sensors that monitor soil moisture, crop health, and can even help predict pest outbreaks. It's all about using data to be more efficient.
So the core idea of remote asset management is still a huge driver across all these industries.
It's fundamental. Whether it's an offshore oil platform, a remote mine, or an unmanned research station, you need that high reliability link for operations, for maintenance, and for safety. Satellite is what makes managing those high-value assets on a global scale possible.
The success of LEO constellation really comes down to the business model. It seems like the entire economic foundation has shifted.
It has shifted fundamentally. The LEO business model is all about leveraging that drastic reduction in upfront cost to deliver a lower total cost of ownership, or TCO, to the customer.
It all comes back to mass production and reusable rockets.
Right. They drive down the cost per bit of data, which allows for competitive pricing, and the revenue streams are usually diversified. You have the direct-to-consumer service, $100 a month or so, supplemented by high-premium enterprise and government contracts that demand very secure, very reliable service and are willing to pay for it.
And the economic model of these LEO constellations, fueled by reusable launches, it fundamentally changes the capital investment required.
The economics are drastically different from the past. The combined effect of low-cost reusable launches and miniaturized, mass-produced satellites significantly lowers the total cost of ownership for the network operator. This lower TCO enables space network operators to reduce the connectivity cost per bit, making satellite bandwidth more affordable for mass market consumption.
That brings us to a critical strategic decision, the need for a thorough total cost of ownership analysis.
This is a core conclusion from the Alpert Research Team's strategic assessment. A common procurement mistake is focusing solely on the lowest initial bandwidth subscription fee or the cheapest ground equipment. An initial cheap network design often means accepting limitations. For instance, ground hardware that can't support advanced efficiency techniques like CCT or advanced ACM. Well, if you invest in lower-tier ground equipment, you may be stuck running the network at a spectral efficiency latency of, say, 1.40 bps. If investing a bit more capex into high-efficiency hardware allows you to deploy CCT and reach 2.07 bps efficiency, the resulting bandwidth savings over the long term will often vastly exceed the initial equipment expenditure over a 5 or 7-year lifespan. Only a comprehensive TCO analysis, factoring in hardware, software, and long-term bandwidth consumption, can accurately determine the true economic viability of a strategy.
So the business models themselves are becoming highly segmented, ranging from just selling capacity to offering full managed services.
The market is maturing, and it requires diversified models. We see retail direct-to-consumer subscriptions like Starlink, large-scale wholesale capacity agreements selling gigabits to cellular operators for backhaul, DTD enablement services, and highly specialized government and enterprise managed services that bundle hardware, security, and guaranteed QoS metrics.
The transformation is just undeniable.
It really is. And what's so fascinating is just how quickly all these pieces have come together to take satellite from being this niche, high-latency tool into a core, competitive part of the global wireless backbone. This overview from the Alpert Research Team should really give you that full integrated picture.
Modern satellite communication has evolved from a specialized broadcast tool into a core pillar of global connectivity, enabling broadband, IoT navigation, and resilient communication infrastructures. With the rise of LEO constellations, AI-optimized networks, and 3GPP standardized NTN systems, satellite communications are poised to serve billions of users and devices worldwide. This Alpert Research Team overview delivers an integrated view of the technologies, architecture, applications, challenges, and opportunities shaping the next decade of satellite-enabled connectivity. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.